Hi student, today we'll discuss about stack. Uh, Stack is very important data structure in computer science. So if you are working in industry, so you probably need to know the good knowledge in stack. So what is stack? So let's try to understand stack in real life. So in the slide you can see there is a stack of pancake. So what does it mean? That you have a lot of pancakes, so you keep them in a stack. So stack has some characteristics. For example, so if you want to take out one pancake from the stack, probably you will take the first one, the top one. And if you want to keep one pancake onto the stack, so you probably keep that pancake onto the top of the stack. So this is nature of the stack when you are keeping something or when you are taking something from the stack. So you can imagine that stack has some characteristics called LIFO. So what does it mean? LIFO is the last in first out. So in the picture we have seen that we are taking pancake on from the top of the stack. So that pancake basically kept at the at last. So the data or the pancake, which one's kept on the stack at last, that was take out at first. So that's why it's called LIFO. That means the last in first out, because the last element push onto the stack will be the first element to be popped up. That's why it's called LIFO. So now if we compare our real life stack with the computer science stack, so it has similar characteristics. So stack is kind of a list that you want to keep several data in a list. We have seen several kind of lists. We have seen array, we have seen linked list. So stack is kind of a conceptual data structures. So if you want to implement stack in programs, so probably you might need to choose one of the data structures. You can choose array, you can choose linked list to implement stack. So basically, to keep data you have to maintain array or linked list, but you can treat them as a stack. So stack also called restrictive data structures, because you cannot insert anywhere into the stack, you cannot delete from anywhere from the stack. So if you go back to the previous image, so we told that if you want to keep one pancake, you have to keep onto top of the stack. And if you want to take out one pancake from the stack, probably you need to take out from the top of the stack. That means inserting something, it should be top of the stack, and deleting something, it should be from top of the stack. So this one has some characteristics, some characters. So you cannot insert or delete into or from anywhere from the stack. So if you implement stack using array, or if you implement stack using linked list, and if you want to treat them as a stack, then you have to maintain these characteristics. So you have to insert from top of the stack, you have to insert delete from top of the linked list or from top of the array. So you know that you already have learned linked list, and in the linked list you maintain head and tail. So you can treat that head is a top of the stack, and you can keep that informations. If you want to delete something from the linked list uh, as a stack, and if you want to insert something onto stack which is implemented by a linked list, then you can keep those head informations, and you can treat them as a head of the stack or a head of the linked list. So that's why it's called restrictive data structures. So if you maintain stack characteristics, in linked list or in an array, so you have to delete from top of the stack, you have to insert onto the top of the stack. So there are several applications of stack. So uh, even if we talk about computer science or in our computers, so our compiler basically maintain stack, uh, uh, you know stack so when they compile several functions, so when we write a programs, probably in a programs we have several functions. So when they compile, when a compiler compiles a programs, they basically take one functions and store onto the memory, because in order to execute a functions we need memory in our computers, and that memory basically in the stack of the computers. So they maintain some stack concept in our memory, and we compiler takes functions one by one, and they keep onto the memory, and they execute they execute those functions, and they after executions they release those memory, and they delete all the functions from the memory. So so this is one application of stack. So here in the slides you can see that the stack is used to store information about parameters and return points for the method that are currently executed. So that's basically talking about our compiler, keeps all the informations of parameters and return points on memory, that basically maintained by stack concept. And other application of stack is if you want to evaluate an expressions, say mathematical expressions. In our computer programs we have several expressions. Say for example, say plus b plus c, we want to evaluate that expressions. So our computer basically use stack uh, concept to evaluate those expressions. So in our following lectures or following class, we will see that how we can use stack to evaluate an expression. So we will see some examples how we can use stack concept to evaluate an expression very efficiently. So these are the some applications. So what we have said, that our compiler use stack concept to execute different functions in a programs, and our compiler use stack concept to evaluate an expressions. So we have seen several library functions, library files, library class. Those are already in Java library files, for linked list and for array. Similarly, for stack also we have several methods or several class. Those are already built in. If you want to create a stack, you can import those files, and you can use those class, and you can use their methods to do some operations. So these are the methods you can see in the slides. So these are the very common method for accessing, for implementing and stack. So you just use those method by creating object of their class. So first one is isEmpty method. IsEmpty method basically try to check whether your stack is empty or not. As I said, that stack is kind of a list. You keep several data in the list. So so in order to check that your list is empty or not, or your stack is empty or not, you can call these isEmpty functions. IsEmpty functions return boolean. So that means if the list is uh, empty, then it returns true, or if the list is not empty, then it returns false. The second one is peek functions. So peek functions return the object at top of the stack without removing it. So we already have seen that in order to insert something, or in order to delete something, we have to deal with the element on top of the stack. So that's why we need to pick the top element of the stack. So the you can see that the peek method basically return e-type data. So e-type is basically, as we have seen several times, it's, it can be any type. So if you keep integer information in the stack, then it will return integers. And if you keep float information in the stack, then it will return float information. Or if you keep string, or if you keep char, then it will return string or char informations. So e basically based on your data that you keep on the stack, in the stack. So uh, the peek method basically return the top element of the stack. That's basically saying that. The next one is pop method. Pop method is return the object at top of the stack and remove it. So peek method and pop method is similar, but there is some differences. Peek method, after it doesn't remove the first element, it only return the first element. So it will return the first element informations to you. However, the pop method will return the top element, and at the same time, after returning, it remove from the top of the stack. So pop method is deleting top element from the top of the stack, and peek method basically return the element from top of the stack. The last one is push method. Push method is you want to insert something onto the stack, onto the top of the stack. So yeah, that's why you are seeing that push method taking some parameters, so or objects. So you are giving some data through the push method, and that push method will be inserted on the top of the stack. And finally it return the item post. So it will return the same item that you post currently, that will be returned to you. So that's why the push method return type is e type, that basically based on your data. And the e object you are seeing then in the argument, in the argument. So this e type basically the type of the data that you are keeping onto the stack. So these are the basic method of stack. So if you want to implement a stack, whether you are using Java library file, Java class, or whether you are using your own code for creating a stack, probably you need to maintain this basic method to to implement a stack. So let's see some examples. Say for examples, you can see the this you can imagine this one is a stack. So this stack, each element contains string. The the first element contains Jonathan, a person name. Then second element contain Dustin. Third one Robin, and fourth one another name, and fifth one other different names. So this is a stack, and it contains several elements, and each element contains one string. Now if you run names.isEmpty method, names is a names is a stack name. So what is the stack name? Stack name is a names. So now if you call this isEmpty method, names.isEmpty method, that should return false, because these names is not empty, the stack is not empty. So you are checking that whether the stack is empty or not. So names.isEmpty method should return false. Now so the last second one is calling names.peek method. The names.peek method, we have learned in the previous slide that peek method return the top element of the stack. So what is the top element of the stack? Top element is Jonathan. Jonathan is the top element of the stack. So when we call names.peek, that should return Jonathan, and Jonathan will be assigned to the last you know last variables. So then if you go to the third method, so names.pop, so pop method says that you should remove the top element of the stack. So what is the top element of the stack? Jonathan is the top element of the stack. Now if you call names.pop, so it should remove the top element of the stack, and after before removing it just return to the uh, it return the top element. So we just remove it, and before removing it we just return that deleted item to the temp variables. So you can see that after deleting Jonathan, now there is no any Jonathan. Now top element is Dustin. So after removing Jonathan, our current top element is Dustin. Now finally names.push. So we know that push method basically inserts something onto the stack. So Philip is a string that you want to insert. You want to insert this string onto the stack and onto the top of the stack. We know that push method, you know, uh, insert that element, insert a data onto top of the stack. So names.push method will push that item onto the stack. So you can see that. So here this one was the latest stack, and after pushing, so now we have a latest stack is this one. So Philip is now top element of the stack. Now if you want to delete something from the top of the stack, then it will delete the Phillips. So you can see that in the example that whatever you insert, it basically insert on top of the stack. Whatever you delete something, it delete from top of the stack. So these are the basic these are the examples of a stack. So now see some examples. Let's see some one more some applications of stack. So this one is one application, say finding palindromes. So what is palindrome? A palindrome is a string that reads same in either directions, left to right or right to left. For examples, kayak. Kayak is a string, is a palindrome because if you read from left to right, it you can spell Kayak, and if you read from right to left, you can read the same thing, Kayak. That's called palindrome string. So if you read left to right, or if you read right to left, so you will get the same thing. So that's why it's called palindrome. Now you can see another palindrome, say I saw, I was, I. And if you read from right to left, you can see that I saw, 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 and I, WAS, was, I. So it's the same thing. Whatever in either direction you read, or either left to right or right to left, you will find the same thing. So this kind of string is called palindrome. So you can check whether any string is palindrome or not. You can check easily using the stack concept. So for example, so you can write a programs, and that program basically reads whether your given string is palindrome or not. Now let's go to some one applications. We can see some method or class that check whether it is palindrome or not. Let's see something on terminals. So let's see one palindrome Java palindrome functions math class. So here in the palindrome class, you can see that our class name is palindrome finder. So in this palindrome finder, we basically use stack concept. So this stack concept, using the stack concept, you can easily uh, check whether that string, that given string is palindrome or not. Say for example, in the class you have uh, a function called dq. So dq function, say for example, say fill stack method. This fill stack method basically, takes some input string. So this is a string. You need to check that whether the given string is, you know uh, given string is palindrome or not. And then you create a stack called char stack. So using, so how did you create that char stack? You use some array dq class. This is a built-in class. You use that built-in class, and this built-in, using this built-in class, you create a stack. That stack basically keep characters, characters. In each element you will have characters. So how do you, keep those character in the stack? You have a for loop. In the for loop, you take that input string, and you take each character of the input string until you finish all the character of the input string, and take that input string and you are pushing onto the stack. That means, for example, you if you have, say for example, if you have some characters kayak, that you have kayak kayak. So now if you want to insert onto the stack, that first element should be, top element should be k. Now first element should be k, then second will be a, then third element will be y, and fourth element will be a, then fifth element will be k. So you can see that we are taking one character, each character one by one, and we are pushing on top of the stack. So this is the same thing is happening. So we get the input string from the users, and we take that user input, and we take each character from the string, and we are pushing onto the char stack. Char stack is our stack that basically keep characters in each element. Now in the second method, this is first method. The first method called fill stack. We taking user input and we filling our stack. Now what we need to do? We need to do that. We have another method called build reverse. So what is build reverse method? Sorry. Let's try again. So what is build reverse method? Build reverse method take the input string again, and that that call that fill stack method that we just analyze this one. After fill stack method, we have the we have stack with the all the all the information in the stack. Now we what we are doing, that we are we are uh, popping from the stack. We know that how to pop. We pop the top element from the stack, and after popping we get that element, and we add that element to some result variables. So we have a result variable that is a string builder type variable that basically keep string informations. So we create a result variables using the string builder class, and that result variable you know that result variable used to keep our popping informations. So we pop from the stack, and after popping we get that element, and that element is append to the result element. So now, so one by one we pop from the stack, and we append that popped element to the result variables. So finally you have to check that your input string will be similar to the result string. Because now, for examples, if you go to the previous examples, kayak, say for examples you have kayak. So this is your kayak variables. Now when we use fill stack method, that fill stack method take characters, this one first, then second one, third one, fourth one, fifth one, and push onto the stack. Say for example, so you have a stack and this is your first element you stack, then you take a and you push on top of the stack, then you take y, you push top of the stack, then you push a and that push onto the top of the stack, then you take k, final k, and you push top of the stack. Now this is your stack. Now what you are going to do, you call the build reverse functions, and that build reverse functions basically pop from the stack and push onto the result variable. Say for example, so you have result variables here, and you append to the result variable all the popped element. So when you popping something from the stack, you pop the first element. Say for example, so you pop the top element k. So then you append to the result element. Then you pop this one top element and you append this a over here. Then you pop this one and you append this one over here. Then you pop this one, then you append this one. Then you pop this one, then you append this one. Now this one was your input string, and this is your result string. Now you can check that whether input string is similar to the result string or not. You can see that you have compared in this isPalindrome method. This isPalindrome method basically compare whether input string is equal to your result string or not. So basically input string, you pass this input string and you call the build reverse functions, and that build reverse functions get some results, and that results basically check whether this is equal or not. So in our example, we can see that input string and result string are equal, so that's why it's a palindrome. So if you try the same other information, that for example which is not a palindrome, say for example if we try Kyle. Okay, so Kyle is not palindrome, let's try Kyle. So you have the results, so you try the fill stack first, fill stack method. So you you know you take k and push onto the stack, then you take a, then push onto the stack, then you take y, push onto the stack, then you take a, push onto the stack, then you finally take l, push onto the stack. Now you call build reverse functions and pop everything. So you take l over here, you pop l, so you pop l, so and append to the results, then you pop a, you append to the results, and you pop y and you append to the results, and you pop a, append to the results, and you pop k and append to the results. Now you can see that the input string was Kyle and the result was Layak. So this is two different things, so that's why this is not a palindrome. So we can easily do some pushing onto the stack, then we pop information from the stack, then you can check that whether the result after popping is similar to the pushing information or not, then we can say that this is a palindrome. So this is one applications how we can say that how we can find that a whether given string is palindrome or not. So how we can use stack to find those informations. So these are the palindrome method that we have seen on the terminals. So DQ method, fill stack method that return a stack that is filled with the character in input string, that we have seen that fill stack method was used to create a stack with all the characters from input string. Then we have seen build reverse method. Build reverse method basically call the fill stack method to fill stack based on input string and return a new string formed by popping each character from the stack and joining this character into some variables and until it's empty. Then finally is palindrome method that basically compare, you know, whether it is true or not, whether input string and the build by reverse string is build by reverse method, uh, that is a string that is built by build reverse method is the same or not, then it returns to, you know, true or false. So these are the methods we have seen on terminals. Now let's see, you know, some how to create a stack using built-in uh, built-in library functions, and how to create a stack using your own code. So let's this one. Let's see first that how we can use stack, how we create a stack using a built-in class. Okay, so here you can see that we have a class called liststack. So liststack class takes a e type informations, e basically based on your data that you want to keep on the stack. Then it implements some stack in interface. That stack interface keep all the, you know, uh, you know, all methods that you have, you want to implement. So basically you can create that stack interface, and that stack interface keep all the method that you need for creating for implementing a list. So now here basically you know, then you can have some list data type, and you know, this is a you created a list, and this is the data, the what you know, this is the name of the list. So this is a list type variables that you can keep any type of informations in the list. Then this is a constructor. In the constructor, so you basically, you know, create some array list, and that means you have you know, you are creating a stack using a you know, implementation using in array list. So this is the example how you create you know, a stack using an array list. So you first you create a list, and that list is allocated using the array list class. Then you have, you know, mm, push method, pick method, pop method, and isEmpty method. So you implemented all this method, and because these methods are coming from the stack interface, you have to have some stack interface. That interface has all these push, all this method information, then you can implement over here. So we understand that in interface basically we cannot implement all the method, but when you want to use those interface, you have to call those method and you can implement those method. So in the push method you can see that we basically add some object into the list. So we know that push method add data on top of the stack. So that's why we are taking some object, some data, and that data is adding to the data, you know, that data, the list. So how do you find this add method? This add method basically coming through the coming from through the array list, because array list has some built-in method that calls add method, so we can easily use that add method for pushing purpose. So then peek method basically try to access the top element from the stack. So before accessing top of the element of the stack, we check that whether our stack is empty or not. We call that isEmpty method. That isEmpty method basically return whether our stack is empty or not. If it is uh, empty, then it return some exceptions, no such element exceptions. That basically saying that how to handle if stack is empty. If stack is not empty, then it basically returns the top element. You can see that the data dot get and the data dot size -1. So the data dot size basically give the size of the stack, and -1 basically give the exact index of the top element, because uh, the index of the list basically start from the 0. That's why we will have size more than index. So if you have 6 element, then the size would be 7. That's why we have the -1 over here. And get method coming from the array list class. Then we have the pop method. The pop method also delete the top element, and we have to check that whether the stack is empty or not. If the stack is empty, then we cannot delete anything, so we have to handle using the exceptions. So if the stack is not empty, then we can remove the first top element. So using the same concept that we have seen in the peek method, the data dot size -1, the data dot size -1, we can use remove method to remove that element. And finally, we can implement isEmpty method, just calling that data is empty, that is empty coming from the array list class. So this is the how we can use implement stack using array list. And we have some stack interface. That stack interface contain all the method. Now let's see how we can create a stack using linked list. So this is the another examples. Similarly, we create a class link stack, and we implement the stack interface. So we know that in order to create some linked list, we have to create a node class, because linked list has several nodes, so we need to handle those nodes. In the linked list lecture, we have seen that how to create a node. So here the node contains two informations, the data and the next node addresses. So there is a two data member of the node. So we have two constructor. So this constructor take data item to create a node, and this constructor take data item and the node reference of the next node reference. So we can create a node using any of the constructor. So before creating a stack, so we can have some top of the stack reference. So you can use head. We basically use head for the linked list. So similarly, you can use top of the stack reference in a similar concept how we maintain handles. So initially top of the stack reference will be null. Then we can implement push, pop, peek, and remove some other isEmpty method. In the push method, we can see that we just call a node up in a node class, and we pass some top stack reference informations and our object, and that object will create a node by calling this constructor, and that will be assigned to our top of the stack. So new element that is just push, that would be our top of the stack. And finally we return the object. So simple thing, push method, we are pushing some object onto the stack, and that will be our top of the stack. And pop methods, similarly we check whether it is empty or not. If it is not empty, then we just take the top of the stack data. So top of the stack reference dot data basically our results, that basically our top element of the stack. So we can remove this top of the stack in our pop method. How we can remove? We can make our top of the stack of the top of the stack, which would be the next element of the previous top of the stack. So we can see that top of the stack dot next would be our new top of the stack reference. So this is the way how we have seen in our linked list how we can remove a node from a linked list. If you want to remove a head from a linked list, we just make the second element as a head. Then our first element will be treated as a garbage. It will be deleted from the memory. So this is the how we can do the pop method. In peek method basically access the top element of the stack. So before accessing, we just check that whether the stack is empty or not. If it is not empty, then we just return top of the stack reference dot data. So we just return the data of the top of the stack element. So then finally, if the stock reference is null, then we can say that our stack is empty. If there is no any element, if there is no any data in the top of the stack, then we can say this is empty. So this is the how we can create a linked list using, or create a stack using linked list. So we have seen that a stack can be implemented using a linked list, or a stack can be implemented using an array list. So you can implement all those methods, push, pop, and is empty method. And similarly, if you don't want to implement this method, you can easily call a a stack class that already have built in Java library, and you can access this push, pop, and the a peek method without implementing those things. So this is all about the stack, and this you should try to program some code that is related to stack. Then you will have the great idea how to deal with the stack. In the next class we will see some more things, some more data structures. And thank you very much for today.